In this we are seeing about buck converter for DC motor speed control with the help of ANFIS controller. This is the buck converter. It is provided to the output of the buck converter is provided to the DC motor of the rating of 180 watts. The input is 100 volt, output will be 48 volt. And here we have provided the speed reference, initially 500 rpm. After 0.25 seconds it is 1500 rpm. And torques, initially it will run at no load condition. After 1 second 0.5 newton meter, and after 1.5 second 1 newton meter, and after 2 second it will be 1.5 newton meter. Here the speed is given to the speed controller. Reference speed and the measured speed is compared, and error is given to the PI controller. The PI controller will generate the DC voltage reference depending upon the error speed, and that DC voltage reference is compared to measured DC voltage, and error voltage is given to PI controller. From that duty ratio will be generated. That duty ratio will be provided for PWM pulse generation. The generated pulses is given to the MOSFET. In this, this is the speed waveform. Initially it is 500, and after 0.25 seconds it is increased to 1500 rpm. In this, if you see, means it is settling at 0.07 second, and when the speed is increased at 0.25 seconds it is settled at 0.52 second. That means the settling time is around 0.27 seconds, and here it is settled at the speed of 1483 rpm. And when the load is increased it is settled at 1480 rpm. For each load condition it is settling at 1480 rpm. And here this is ANFIS controlled DC drive with the help of buck converter. In this, same condition is given. Initially the speed is 500, and after 0.25 second it is 1500. Then initially it will be running at no load condition. After 1 second it will be 0.5 newton meter. After 1.5 second it will be 1 newton meter, and after 2 second it will be 1.5 newton meter. In this, the speed is provided here. The speed is settled at initially 0.06 second, and here it is settling at 0.37 or 36 second. And in this, if you see, means the speed is around 1499 rpm. At any load conditions it is settling at 1499 rpm. So compared to the PI controller where the speed is 1480 rpm, here the accuracy is higher. That means steady state error is low. Similarly, settling time is reduced compared to PI controller. Under different speeds and different load conditions, the ANFIS control performs better than that of PI controller. This is the working of the buck converter based DC drive with the ANFIS controller.